So hello students, in this session, we look at a few examples of factorization, different techniques. Okay, let us start with the first problem. Factorize x square plus y square plus x plus y plus 2xy. So this was one of the problems given as homework. If you have tried solving it, so you have x square plus y square plus x plus y plus 2xy. There are 5 terms, isn't it? So it might seem like grouping or I have to split the middle term or something because odd number of terms. But then if we observe carefully, I told you we have to look for identities within the problem. So if I take x square plus y square and if I take 2xy, what do I get? Yeah. So we know that, you can write it somewhere here. We know that x plus y the whole square is x square plus y square plus 2xy. Just that this identity is separated out. It is disintegrated. We have to look at it as a whole. So we'll just write them together. So x square plus y square plus 2xy plus x plus y. Now when you look at this, you'll be able to relate it to x plus y the whole square plus, now you have x and you have y, x plus y. There's nothing common. When there's nothing common, I told you can take out one common. So this amounts to 1 into x plus y. So now what do you have here? If you're going to consider x plus y as some, let's say a, so you have a square plus 1 into a. Yes, so what is a square? A into a plus 1 into a. So when you take out 1a common, you're left with another a plus 1 inside. Back substitute for a, you will get x plus y into x plus y plus 1. Okay. Yes. So let's move on to the next question. Okay. So the next question out here will be, again, I'm taking it from your homework problems. 9x square plus 3x minus 8y. Okay. So 9x square plus 3x minus 8y. 9x square plus 3x minus 8y minus 64y square. Okay, let me just relook at the problem because we need to copy the question correctly. Remember, this is very important. So 9x square plus 3x minus 8y minus 64y square. Be careful with the signs. So again, the same thing, but there are 4 terms here. And I told you have to think of all the identities possible. Grouping, identities in grouping, then a square minus b square, splitting the middle term. It's not like there's one blanket rule for all the factorization problems. Sometimes there'll be a mix and match, like you'll have to use multiple identities in the same problem. So this is one such example. If you look at this, I'll have to use, see, when I see squares, it reminds me of a square minus b square. Okay, so it's not like there's only one way of solving. You might be able to arrive at the same solution or same method of factorization, I mean, using different strategies. So now I'll take these two. And why did I take these two? Because I see x square and y square, and 9 is a perfect square and 64 is also a perfect square. So 9x square minus, so with practice, you'll be able to understand now which method am I going to adopt, what to do next. So when you do a few basic types of problems, you'll be able to get the flow. And then you'll be able to understand which method, which strategy to apply. Sometimes there are more than one, there will be more than one possibility. Okay, so now the same thing. So I'm just trying to put the perfect squares together. I can write 9x square as 3x the whole square and 64 is 8 square. So 8y the whole square plus, yeah. Now if I look at 3x minus 8y, I told you there's nothing common. When nothing is common, we are going to assume that 1 is common. So 1 into 3x minus 8y. So 1 is such a versatile number. See, it is helpful here because in factorization, it will help you to break it up into factors. So 1 is a factor of every number. So we know that. Now look at this. 3x square minus 8y square. What is a square minus b square? A plus b into a minus b. So in line with that, you will be able to get this as 3x square minus 8y square is 3x plus 8y. If you look at 3x as a and 8y as b. So a plus b into a minus b. And of course, keep that 1 aside. 3x minus 8y. So what do you see? 3x minus 8y is common, isn't it? So now it is, so 3x minus 8y, take them together, and then inside the brackets you can use square brackets and you can use round brackets, parentheses to distinguish. So we have 3x plus 8y because we have taken out 3x minus 8y outside, isn't it? So 3x plus 8y, and of course that after the plus there's a 1. So this is the factorized form. There's nothing we can do further about this. Okay. So here we have actually used two things. We have used grouping, and then we have used a square minus b square. Okay. Let's move on to the next type of problem, which is little different. So I'll just go to a new page. Just a minute. Yeah. Let me go there. And we have x square minus 3x. So again, the same thing, factorize. So the question is, just write it here. So you're going to factorize x square minus 3x, okay, into x square minus 3x minus 1 minus 20. This is the other homework problem which I had given. So x square minus 3x into x square minus 3x minus 1 and then minus 20. So this is also an example, another example of substitution here. So x square minus 3x, and then I see the same pattern here. So that's what I told you in algebra, I have to look for patterns. So x square minus 3x, let me call it as, let's say, some y, or you can use any variable. So this amounts to y into y minus 1 minus 20. So we'll do the back substitution for y later. So now I'm going to get a quadratic in y. See, if I multiply, now if you see that earlier I had x square minus 3x, yeah, and then I had this x square, the other x square. When I'm going to multiply, I would have got a biquadratic. Last year you learned, isn't it? Biquadratic, power 4. So I'm familiar with squaring, I mean with quadratic, with square I'm familiar, where I can use splitting the middle term. So that's why I'm going to make the substitution. All right. So y into y minus 1 minus 20, because I saw that pattern repeating. So wherever there is x square minus 3x, I have placed the y. And now I need to multiply. Y into y is y square. Y into minus 1 is minus y minus 20. Now this is familiar to you, isn't it? Splitting the middle term. We have done lots of this last year, and even this year we have recently worked on this. Minus 20, you can get it as minus 10 into, and this is a negative product, right? Because y square means 1y square. If you relate it to your ax square plus bx plus c form, I've told you this. We'll have ay square plus by plus c. A into c, a is 1, c is minus 20. So you get minus 20, you decomposed as, you can, one factor will be negative, one factor will be positive, because product is negative. But then I need to get b. What is the b there? It's negative 1, isn't it? So, okay. So which other way can I get this? Yes. If I look at minus 5 and 4, and why not plus 5 and minus 4? Because I want negative 1. That's why I'll have to decompose this minus 1 by, minus y means minus 1 by. So I'll move on to the next page. Okay. So that would be y square Okay, I'm just writing it a minute. Yeah. So y square y into y minus 1 minus 20. So y square minus y minus 20. I'm decomposing it as minus 5y plus 4y minus 20. Isn't it? It's just I've split that middle term, as you can see here. And now it's again grouping. Okay. So y into y minus 5 plus, of course, 20 is 4 into 5. You'll be taking out 4 common, y minus 5. So now in effect, it becomes y minus 5 into y plus 4. Okay, we have factorized the polynomial in terms of y. But remember, we have to back substitute for y. What is y actually? What is y? It is x square minus 3x, isn't it? So if you, I'll take it to the next page. Okay. So it will be y minus 5 into y plus 4. So it will be, yeah. So x square minus, let's just do the substitution. X square minus 3x minus 5 into x square minus 3x plus 4. Okay. Now, we have got two factors, rather two quadratic trinomials. We are multiplying them and we are going to get back that original thing, that is the sum, x square minus 3x into x square minus 3x minus 1 minus 20. Now, can we further factorize this? I had discussed this with you. See, for that you have to check with discriminant, isn't it? For the first factor, if you look at x square minus 3x minus 5, if you look at x square as 1x square, or you'll get your d. D is b square minus 4ac minus 3 the whole square minus 4 into 1 into negative 5, which is 9 minus into minus plus 20, which is 29. It's not a perfect square. How about the second one? Look at x square minus 3x plus 4. That will tell you whether it is factorizable or not. Okay. So what is that? 1x square. If you look at it this way, d is equal to b square minus 4 into 1 into 4, which will give me minus 3. Yes, it will be 9 minus 9 minus 16, which will be minus 7, which is again not a perfect square. There's no way I can actually, I cannot split it up further. I told you this one. So otherwise, we would have been able to, if you're able to split it, we would have split it further. If it's a quadratic, we would have got two factors, but that's not possible in any of the cases. So we leave the answer as this, which will be x square minus 3x minus 5 into x square minus 3x plus 4. Okay, let's just go on to the next topic. Now I spoke about factorization and x square minus 3x minus 5 into x square minus 3x plus 4. Okay, so now somewhere if I feel I've gone wrong either in the calculation or in the intermediate steps, how do I cross check? So the answer is simple. I've already discussed in class. If you know the, like factorization is the reverse of multiplication. When you multiply two quantities, you're going to get the product. If you take the product and if you decompose it, you'll get the factors. So if I'm going to multiply this, let me see if I'm going to get the original equation. So that's what I have to do, isn't it? If I look at this, it will be, I'll have to just take these two together. So what they have done is they have taken this as, let me call it as y, because I see the patterns here. So y minus 5 into y plus 4. So when I multiply, I should be getting y into y is y square plus 4y. It's just multiplication of binomials now. Minus 5y minus 20. Okay. And this, of course, I can write this as y square minus plus 4 and minus 5 will decompose to minus 1y minus 20. Y into y minus 1 minus 20. That's exactly what we got, isn't it? What was that y? That y was x square minus 3x into x square minus 3x minus 1 minus 20. So this is how you will approach. So first you will multiply, you will combine them and try to bring them to a format that we are familiar with. In this case, splitting the middle term. So that x square minus 3x has been reduced to y, and then you have to back substitute. I think this is enough for the session for today. I hope this has been helpful to you. I'll try to get back with more examples, the other homework problems in the next session. Okay.